What if I told you that right now, astronomers are looking at a handful of brand new worlds that look shockingly like our own? And what if I told you they're just a stone's throw away, cosmically speaking? We aren't talking about distant frozen rocks. We're talking about planets that could have oceans, continents, and maybe, just maybe, life. In the next few minutes, we're going on a trip to these new Earths to see what life could be like just a few light years from home. It turns out the universe next door is a whole lot weirder and more wonderful than we ever dreamed. For as long as we've looked at the night sky, we've asked the question, are we alone? Well, that question is starting to feel a lot more urgent, because the answer might be closer than we think. Over the last few years, a revolution has been happening in astronomy. Using technology that was pure science fiction a generation ago, scientists have confirmed the existence of thousands of exoplanets, worlds orbiting other stars. And as of late 2025, that number has blown past 6,000. Among them, a few special ones stand out. They're often called super-Earths, rocky planets bigger than our own, and it turns out they're everywhere. One of the most exciting recent finds is a planet called Wolf 1069b. It's just 31 light-years away, which is basically our backyard. What makes it so special is that it's about 1.26 times the mass of Earth, which tells us it's a rocky world like ours. But here's the kicker. It orbits right in the middle of its star's habitable zone. This is the Goldilocks Zone, that sweet spot where temperatures are just right for liquid water to exist on the surface. Not too hot, not too cold, and it's not alone. Astronomers are also getting incredible new looks at planets like Gliese 12b, a temperate world about the size of Venus. And of course, there's the famous TRAPPIST-1 System, an amazing family of 7 Earth-sized planets orbiting a tiny star, just 40 light-years away. Several of them are also in the habitable zone, making the system a perfect laboratory for studying how life-friendly worlds might form. These aren't just points of data anymore. They're becoming real places. Destinations we can finally start to explore with the power of our telescopes. So, how are we actually finding these new Earths? It's a bit of a cosmic detective story. For the longest time, seeing a tiny planet next to its blazing star was impossible, like trying to spot a firefly next to a searchlight. So astronomers had to get clever, and they developed some truly ingenious ways to hunt for these hidden worlds. One of the most successful is the transit method. Imagine staring at a star, just a tiny speck of light. If a planet crosses in front of it from our perspective, it blocks a teeny tiny amount of that light, causing the star to dim just a little. We're talking a dip in brightness of less than 1/100%. But our telescopes, like NASA's TESS satellite, are sensitive enough to spot it. By watching for these repeating dips, we can figure out how big the planet is and how long it takes to orbit its star. Then there's the radial velocity method. A planet doesn't just orbit its star. Its gravity actually tugs on the star, making it wobble back and forth. By measuring tiny shifts in the star's light, we can detect that wobble and figure out the planet's mass. This is exactly how Wolf 1069b was found, using the super-precise Carmenes instrument in Spain. And now we have the undisputed game-changer, the James Webb Space Telescope. With its massive mirror and incredible power, JWST isn't just finding new worlds. It's doing something we've only dreamed of. It's sniffing their atmospheres. By capturing the starlight that filters through a planet's air during a transit, the telescope can look for the chemical fingerprints of gases like water vapor, methane, and oxygen. Potential biosignatures that could be a major clue that something is living there. Alright, let's take a tour. You'll need your imagination for this because we're visiting some of the most amazing places in the known galaxy. First stop, Wolf 1069b. As we get closer, the first thing we'd notice is the light. Its star is a red dwarf, smaller and cooler than our Sun, so it casts this permanent reddish twilight across the whole world. The planet is also tidally locked, meaning one side is trapped in eternal daylight, while the other is frozen in constant night. But don't just picture a world of fire and ice. The most interesting part of Wolf 1069b would be the Terminator line, that twilight zone separating day from night. Here, temperatures could be perfectly mild. Scientists think that if it has an Earth-like atmosphere, the average temperature could be a comfortable 13 degrees Celsius or 55 degrees Fahrenheit, allowing liquid water to form vast oceans and lakes. Next, we're jumping 48 light-years away to the super-Earth LHS 1140b. This world is another top contender in the search for water. Recent observations from JWST have opened up two incredible possibilities. Based on its density, it could either be a dense ice world with a hidden ocean under a global ice shell, or it might be a true water world, with up to 10–20% of its mass being water. Imagine a planet with no continents at all, just one single planet-wide ocean under a cloudy sky. Finally, we arrive at the crown jewel of the exoplanet world, the TRAPPIST-1 System. 7 rocky worlds, all packed so tightly around their star that if you were standing on one, the other planets would hang in the sky like our moon, sometimes even bigger. The big star of the show here is TRAPPIST-1e, a planet almost exactly Earth's size and orbiting right in the habitable zone. Recent JWST data has delivered some thrilling news. It likely doesn't have a thick, puffy hydrogen atmosphere. That's a huge step, because it opens the door for a secondary atmosphere created by volcanoes and geology, just like on Earth. While it's not a confirmation yet, hints of a nitrogen-rich atmosphere are starting to emerge, raising the electrifying possibility of a watery, temperate world right next door. This is where the science gets really fun and speculative. What could life actually look like on these planets? On a tidally locked world like Wolf 1069b, life would evolve under a sun that never moves. Plants on the day side might not be green. They might evolve deep purple or even black pigments to soak up every bit of energy from the dim, red star. And in the twilight zone you could find glowing bioluminescent forests lighting up the perpetual dusk. Animals might have enormous eyes to see in the dim light, or maybe they'd navigate using senses we can't even imagine. On a water world, like LHS 1140b might be, life would be totally aquatic. With no land, the ecosystems could be incredibly deep and complex. Picture creatures that drift on planet-wide currents, feeding on alien plankton, while massive predators grow to unimaginable sizes, unbound by the limits of gravity on land. In the deepest, darkest parts of its ocean, life could be huddled around hydrothermal vents, powered by the planet's internal heat instead of starlight. And in the TRAPPIST-1 system, the planets are so close together it raises another wild idea: panspermia. Not life jumping from star to star, but from planet to planet. If a big asteroid hit one of the worlds, rocks carrying microbes could easily be thrown into space and land on a neighboring planet. It's totally possible that if life started on one TRAPPIST planet, it could have spread to the others, creating a connected web of life across an entire solar system. Okay, as mind-blowing as all this is, let's take a deep breath. Finding a truly Earth-like world is incredibly hard, and the challenges are huge. Many of these promising planets orbit red dwarf stars. These stars are common, but they're also known for being moody. They can blast their planets with powerful stellar flares, which could strip away an atmosphere and boil off any oceans. A planet can be in the right zone, but if its star is too hostile, it's a non-starter. Being tidally locked also has its downsides. One side of the planet could be a scorched desert while the other is an ice flop. Life could only exist if there's a thick enough atmosphere to move heat around and create a gentle climate in the middle. We've already seen with JWST that TRAPPIST-1's innermost planets seem to be bare rock, a sobering reminder of how fragile an atmosphere can be. And even with the awesome power of JWST, getting a definitive "we found life" signal is a monumental task. An atmosphere with oxygen and methane is a great hint, but those gases can sometimes be made by geology, not biology. We'd have to rule out every other possibility before we could even start to whisper the word life. The search requires patience, and we may have to wait another decade for the next generation of observatories to get an even clearer picture. Every new discovery, from Wolf 1069b to the worlds of TRAPPIST-1, adds a new piece to one of the biggest puzzles in human history. Each of these planets teaches us more about what makes a world a home, and what they're showing us is that the basic ingredients, rocky planets in temperate zones, aren't a fluke. They are everywhere. We are officially moving from an era of just counting planets to an era of knowing them. We're becoming cosmic map makers, sketching out the features of worlds light years away. The data coming back from JWST isn't just numbers, it's the first draft of a travel guide to our galactic neighborhood. Just 30 years ago, we knew of exactly 0 planets outside our solar system. Today we've confirmed over 6,000, and we're just getting started. The ultimate question of whether we're alone is still unanswered. But for the first time ever, we have the right tools to seriously begin the search. We're no longer just looking up at stars, we're looking at worlds. And as we continue to explore these new potential Earths, we're not just looking for aliens, we're looking for a deeper understanding of our own place in the universe. The journey is just beginning.